Hey guys, so in this video we are going to import the player sprites into Scratch and start implementing the player movement. So I've already created a new project from Scratch, a default one, so we can go along from the beginning. So the first thing I'm going to do is remove the Scratch cat. We don't need it, and I'm going to import or upload a new sprite. And in the sprites, so let me just Space Invaders, sprites, okay. And now I'm gonna choose the sprite of the player. Okay, so here it is. Here we have our player, and you can see that I only imported one sprite for the player, the first one. So then I'll come here in the costumes and I'm going to import the other ones. We are not going to use it at the moment, but since we are importing the costumes, the player has everything that we need later. So I'm going to import also these two other costumes. So right now we have the default sprite and we have the sprite for the explosion. One thing to notice is that the costume that gets selected is the one that is actually shown in the game. So when we are creating the sprite, we should always remember to select the default costume. So that's the one we have here. And another thing I'm going to do is change the color of the backdrop because in our game the backdrop is totally black. So I'm just going to select backdrop, come here to the backdrops and use the paint bucket to paint it black. Nope, it's not painting. What? Okay, yeah, I remember something about this. I'm going to create like a rectangle, a black rectangle. I don't know why the paint bucket doesn't work. I'm not entirely sure, but this solves the problem. And now we can go back to our player. Okay, so we have the sprite for the player with the default costume. Now we need to position the player in the starting position. And here I'm going to go back to my Figma design that I have for the game, and you can see that the player is at this position. Now, we need to understand where to place the player. Okay, so on the axis, we're going to place the player in the center. Remember that that Scratch, the coordinate system in Scratch, so it works something like this. So we have, in terms of width, we have 480 pixels. Just put here, so we have 480 pixels in the of width, and we have 360 of height, our play area. I'm talking about the play area, so here we have 360. And another thing to remember is that the the origin of the play space is exactly at the center. So we might assume that the origin is on top left or top right. I mean, in this case, it's exactly in the center. So in terms of coordinates, if we had something like this, I'm going to change to this and I'm going to put another axis here. Okay, so this is our two axes and the coordinate here in the center would be 0, 0. And this is something to think about and to actually important because we are going to need to know this when we are trying to find out the exact position for each sprite in the game. So for example, our player, it's over here. So like I said, it's in the 0 position in the x-axis, and in the y-axis, we need to find out where the position of the player is. So if the height is 360, it means that the position here is going to be half of the height, so 180, and negative. Because also another thing that I can put here is that this is positive and this is the negative. And in terms of the x-axis, this is a positive and here is a negative. So, no, we can also put here. So this is half of the width and a negative value, and this is half and a positive value. And the same here. So here we have 180, and here we have, well, I already had this here, and here we have minus 180. So when we are positioning our player, I can see that the position here in Figma won't work because the coordinate system works in a different way. I mean, the center of the sprite here, of the image here, is not in the middle of our frame. So I'm just going to check what's the distance between the player and the end. I'm going to remove this. So the distance between the player and the end or the bottom of the play area, in this case is 12 pixels. And so in this case, the position is going to be 180 minus 12. But 180 minus 12 would give us the point here where the sprite begins, like the bottom of the sprite. And in Scratch, the position of the sprites are also exactly in the center. So if our sprite is 20 by 20, it means that the position of our player is going to be 180 minus 12, we are here, minus 10, we are in the center. So 170, 158, if I'm not mistaken. So yeah, 158, 12, 16, 170, 180. Yeah, it's correct. So this is the exact position that we want our player to start with. And now that we have our player and the costume and it's in the right position, we can start to add code to create the player movement. So as we've seen, the player can only move left and move right. So the first thing that we need to do is to detect when the player presses one key or another key. So almost everything starts with this block when the flag is pressed. And now to change the position of the player, we can use two different blocks. We can use the move block, or in this case, since we are only moving left and right, we can use the change x by 10. And there is a difference between these two blocks, despite they look the same, but there is a slight difference. The change x by something, if we can always double click on the block to see what it does, and you can see that our player is just walking. In this case, if it's by 10, since it's a positive number, it's moving to the right. If we change to a negative number, it will move to the left. But if we try move 10 steps, it's exactly the same. Now, the difference between these two blocks is related to the player direction. Because if we go here to the direction, we can see that the player direction is 90, which is facing to the right. And so the move block works with the direction of the sprite. So since the direction of the sprite, since the sprite right now is aligned to the right, it means that when we are moving on the x-axis. But if we change, and for example, I'm going to put like on a 45 degrees, now if I change x, it will continue moving our sprite on the x-axis, I mean to the right and to the left, but now when we press the move steps, it's going to move in the direction that it's facing. So it's going to move in the positive value, but not on the x-axis, but on the direction that the sprite is facing. And that's an important distinction. I usually tend to use change x because I don't want to be worried about directions. In this case, it doesn't matter, but that's a personal preference. I'm going to reset all the values back to the beginning. So x is 0, y is minus 158, and the direction is 90. And now we can see how to move the player. So if you want to move the player, we need to catch the moment when the user presses in this case, the left arrow key or the right arrow key. So to catch these events, we can use two different ways. I'm going to show you both, and then we are going to choose one of them. One of the ways is to use an event block when you can just choose which arrow is pressed. This is the easiest way, but I don't like it that much because we need to have different blocks. So when the left arrow is pressed and we have the code, when the right arrow is pressed and we have the code, when the space for shooting is pressed, and so forth. So I don't like this block very much. I prefer the other one, but this will stay here so we can know that we have. The other one is on the sensing category, and you have this, sorry, not this block. Yeah, mistake. This one. So we have on the sensing, we have this block, it's like key something, in this case key space is pressed. So let's change it and let's do, okay, when the key right arrow is pressed, something happens. And now we need another block. We need a block that will run when this key is pressed, or if this key is pressed, then we can do something. And here we introduce another block, which is in the control category, and we have the if-then block. And how this block works is that wherever it's inside here, or when what's inside here is true, it will run what's inside the block. So in this case, we can put this block here, and it will work like this. So if the key right arrow is pressed, then run whatever it's inside this block. And what we want to put inside this block is the change x by 10. So if the key right arrow is pressed, then we can change x by 10. This is how it works, and this is an if-then condition. So an if-then condition needs a condition here that returns a true or false value, and when this condition returns true, it runs what's inside the block. Now we can, the first thing that we probably try to do is to just, okay, so I just connect this to the red green flag, I click it, and if I press the right arrow, it should work. But it doesn't work, and why? It doesn't work because we are just checking for this exactly on the moment when we press the green flag. So this would only work if we press the green flag, and exactly at the same moment we press the right arrow. Since we don't do it, the program ends and nothing happens anymore. So what we need to do is to keep checking on this condition, keep checking on this event actually, and while the game is running. So not only once, but keep checking while the game is running. And to do that, we have another block, which is the forever block. And this is a block that, as the name implies, it runs forever, which says that the block runs whatever it's inside, and you can see this little arrow here in the bottom says that, okay, the block will run whatever it's inside, and when it reaches the bottom of the block, it will start again from the beginning. So it just keeps running on a loop, and that's what we need right now. So when the green flag is clicked, we start a forever block, meaning that we start a loop that will run forever, which means that while the game is running, this loop is also running. And now we check for the key press inside the forever block, which means that this block is running in a loop, and we are constantly checking if the player is pressing the right key. And each time the player presses the right key, the right arrow, it will change the position by 10. So now we can start, and you can see that when we start now, everything gets highlighted, which means that this is running, and the program didn't stop, so didn't stop automatically. So right now we need to stop the program. if we want, because right now the program has a loop that's running forever while the program is running. And now, if we press the right key, the ship will move. The ship or the player will move to the right. Maybe 10 is a lot, because you can see that it moves a lot. So I'm gonna change it to 2. And now, let me see. Okay, now what we need to do. We need to always remember about this in Sprite is that we position the sprites at the beginning, and when we run the program and we change the position of the sprites, they don't reset when we stop the program. So you can see that we had our sprite on the x0, we just changed its position using the right arrow, and now it's on the edge of the screen, and it didn't come back. So we need to do this manually. But we are not going to be doing this every time the program is run. So we need to do it in code. And the way to do it, the way to reset the player position is when the green flag is clicked, we want to make sure that the player is in the right position that we want. So we can use the block go to position X and Y. In this case, when you drag this block, it will use the actual position that you have already set for the sprite. So this is the exact position that we want. And so when the green flag is clicked, the player goes back to the original position and then it starts the block. So in this way, we are making sure that every time the game starts, the player starts in the correct position, and then we can change it. So right now, I can move the player. I think this speed is a little bit better. And when I stop, the player is on the wrong position, as you can see, but when I start again, it resets to the original one. And you can also just click, because this might look a little bit weird, at least for me. So what I usually do is I just click here, double click on the block, and it will apply to the player. And now that we have the player moving right, we also need the player moving to the left. And it's exactly the same as this block, but we just need to change the parameters. So we can duplicate the if block. Let's just connect it on the bottom of the other one and change this. So if the left arrow is pressed, then we're going to change x by -2. And remember, positive values are to the right, negative values are to the left, positive to the top, negative to the bottom. And now we can run our program and you can move the player to the right and to the left. And that's the basic thing about the movement of the player. What are we missing right now? Yeah, maybe one thing we can change is that the player cannot reach the edge, because you can see that right now the player, when reaches the edge, half of the player gets out of the screen. Why this happens? Because like I said before, the center of the sprite, or the position of the sprite, is the center of, or the position of the actor is the center of the sprite. And so the position of the player can be the maximum of 240, is going to be on the center of the sprite, and so half the sprite is going to be out of the screen. So we can change it. We can limit this this position of the player. So how can we do this? So we need to make sure that the player will only move when its position is not greater than 240. Not in this case 240, not 240, but 230, because the player has 20 by 20. So we need to make sure that the max position that the player can have is 230. So the other half keeps visible on the screen. How can we do that? Well, we can go here to the operators. And like I said, the if block only runs what's inside when the condition here is true. And what we can add here is another condition. And what condition in this case what is the condition that we want. So we only want to move the player to the right when his position is less than 230. So we can select this block, which is less than. We can put here 230. And now we need to access the position of the player. Position of the player, we can go to the motion category, and we have here variables that represent the position of the player. And we have the X position of the player. This represents the current X position that the player has at that moment. So right now, what we want is that we want to change X by 2 when the key right arrow is pressed and the X position is less than 230. So we need another block, which is the AND block. And the AND block allows us to combine two different conditions into a single one. So what this means, what the AND block does, is that it returns true. I mean, all this is going to be true when both the conditions are true. So the change X by 2 will only run when we press the right arrow and the position of the player is less than 230. Let's see if this is working. So we can keep pressing, and yes, now the player does not go off the screen. And we can do exactly the same for the other one. So left arrow and the position, here is not going to be a less than, it's going to be greater than. The X position is going to be greater than minus 230. And we can put this here. Let's just check if it's working. And yeah, it is working. So now the player does not go off the screen. Yeah. The project could not save, I don't know. Yeah, okay, something happened. So what have we seen here? We have the forever block, we have the if then block, we have how to detect key pressing, changing the position, and the AND block. I was saying that the AND block, besides the AND block, you also had the OR block. And just to explain the difference, the AND is true. I mean, the AND returns a true condition or returns a true value when both the conditions are true. So when the player is pressing the right arrow and the position is less than. The OR block, on the other way, it returns true when one of the conditions is true. And we could not use this here because we want both conditions to be true at the same time to change the player. Because otherwise, if you use the OR block, every time the player would press the right arrow, this wouldn't mind because this is true, one of the conditions would be true, and so it would run what's inside. So just we'll get back to this on some other video, but I just remember that maybe I should explain this right now. And this is the basic stuff about moving the player. Yeah, so on the next video, we're going to see how to make the player shoot the missiles. That's it. Thanks.